Hi guys, this is Mrs. Renfro. I wanted to share with you our lesson for today. For those of you that are remote, I guess we had some technical difficulties with our Google Meet, and the screen for some reason was frozen for you guys, and you couldn't see this. So, I wanted to share this. We are starting on page. Move this out of the way here. Page 39. I'll hide that so that's not showing. Page 39. And we are working with ratio tables. So it says a punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch of punch. And it tells us to draw counters for the containers of soda and the containers of juice. So first we have, it says we're making 1 batch. If we make 1 batch, we have 1 container of soda and 3 containers of juice. So we need 1 soda and 1, 2, 3 juices. And it says we're making 2 batches now and not just 1. So we need another soda and another 3 juices. So the ratio now for the new one is 2 sodas and 6 juices. Now it says draw red counters to show the number of containers of soda and draw yellow to show the number of juice needed to make 3 batches. So we have 1, that's 1 batch. This is 2 batches. And then the 3rd batch. So we have 3 sodas and 9 juices. Okay? So find the ratio in simplest form of soda to juice needed to make 1, 2, and 3 batches. So we had 1 to 3 for the first one, 2 to 6 for the second one, and 3 to 9 for the last one. So what do we notice? Well, we have 1, 2, and 3 for the number of batches, because that's the amount of soda. It's the same for both. And then we have 3, 6, and 9. So if you look at this, we're taking 1/3 times 2 to get 2 6. We're taking 1/3 times 3 to get the 3 9ths for that one, okay? So we are multiplying to increase. Okay? All right. Now the next page is page 40, and we are doing equivalent ratios here. The quantities in the opening activity can be organized into a table. This is called a ratio table. Sorry, I did not get my pen back. There we go. A ratio table, because the columns are filled with pairs of numbers that have the same ratio. So if I was making this punch for, I don't know, a baby shower or a wedding shower or something like that, I would want it to be consistent. I would want it to taste the same if I had 1 batch or 2 batches or 3 batches. So that's why this ratio is important. We want the ratio of soda to juice to stay the same, even though we're increasing the servings, okay? So equivalent ratios is what this is using. They express the same relationship. So the recipe is the same, just the quantity changes, okay? All right, now for example 1, to make yellow icing, you need 6 drops of yellow food coloring to 1 cup of white icing. And they've put this in the table here. How much yellow food coloring would you mix with 5 cups of white icing to get the same shade? So we want 5 cups of icing in the table here. And we're going to look at what we need to do to increase it. So 1 times 5 is 5. 6 times 5 is 30. So you would need 30 drops. Okay? And then it would have the same color. It would be the same consistency. Example number 2. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine about how many hot dogs he ate every 2 minutes. So for this one, we're going to need to divide, right? Not multiply. We're getting smaller. They had 12 minutes with 66 hot dogs. We want to make it down to 2 minutes and find out how much. So you can do this one of two ways. The way they've done it is they kind of broke it down into steps. So you can kind of do it more mentally that way. So if we have 66 hot dogs and 12 minutes, if we divide that by 2, we get 33 hot dogs in 6 minutes. And then we can divide that by 3 and get 11 hot dogs in 2 minutes. So he ate about 11 hot dogs every 2 minutes. Now, there's no reason that you couldn't divide both of these by 6 if you really wanted to do that, and you would get the same answer, okay? So it doesn't matter how you do that as long as you get that answer. All right, now this question for the got it here, the A, this is very relevant. If you're a nurse, you need to know how long the IVs are going to take. A patient receives 1 liter of IV fluids every 8 hours. Now, if that's what a doctor has ordered, for them to get 1 liter every 8 hours, and then the doctor says, I want him to have a total of 4 liters of IV fluids. So the nurse would have to figure out how long that's going to take and set the machine and everything so that it would be at the same rate. So if we have 1 liter every 8 hours and we want 4 liters, I can just take 1 times 4 and get 4. 8 times 4 would be 32. Okay? So we have 32 hours that it would take for that person to get those 4 liters of IV fluid. Okay? Now, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount needed for 4 cups of cranberries. Now again, we could just go straight to the problem here and say 16 divided by 4 is 4, or we could meet halfway in the middle and kind of work it slowly. So I'm going to say 8 here, because if I do 16 divided by 2, I get 8, and 8 divided by 2 is 4. So then I can do 12 divided by 2, which is 6, and 6 divided by 2, which is 3. Okay? Now again, I could have done 16 divided by 4 because 2 and 2 is 4, and 2 times 2 is 4 here. So they're going to need 3 cups of sugar. 3 cups of sugar to get 4 cups of cranberries. Okay? Okay. The next page, page 41, we are talking about scaling. Scaling is where you want to make it smaller. So multiplying or dividing 2 related quantities by the same number is called scaling. So you can make it smaller or bigger, but it has to have that same ratio. Kind of like model trains are to scale model cars. If you have a dollhouse, it might be to scale of a real house, and everything would be proportionate, like the chairs and the tables, everything would be the right size for a real house if it was bigger. So it looks right, okay? So what we can do with this, we're looking at, there are 10 cans of corn for $4. We want to find how much it costs for 15 cans. The problem here is that we cannot take 10 times anything and get 15. So we need to look at 10 and 15 and find something that works to put in the middle there. Make it maybe a little smaller so that we can use it as a middle ground. So 10 and 15 are both divisible by 5, right? So we could put 5 in the middle and see how that works. Now, But here's the problem. We need 10 and 4 to both be divisible by the same number. So to get 5, I divide by 2, right? That works perfect for this because I can divide 4 by 2 and I get 2. So that worked out great. So whatever you're going to put here, it needs to be able for you to divide the top and bottom number by the same number, the 2, to get this 5 that's in the center column, okay? Now I can take 5 times 3. 2 times 3 is 6. So now we have our scale here. We find out that it is going to cost $6 for 15 cans of corn. So we had to scale back to find out how much 5 cans were so that we could go forward and get the 15 cans, okay? I know it sounds kind of backwards, but that scaling is very handy sometimes. All right, so number 4, Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? Okay, so 14 hours, 8 lawns. We want to find out how long it takes for 49. So is there a number by which you can multiply 14 to get 49? No, there's not. That doesn't work, does it? So we need to scale back to a number that is divisible. 49 and 14 are both divisible by 7, right? 7 times 7 is 49. 2 times 7 is 14. So that works. Then we can scale forward to the 49, okay? So the number of hours, we do 14 divided by 2 to get 7. 8 divided by 2 gets us 4. Now we want to take 7 times 7 to get 49. 4 times 7 is 28. So Joe can mow 28 lawns in 49 hours. And this is also a relevant question. If someone is in the lawn mowing business during the summer and they want to work 49 hours a week, they don't want any more than what they could handle, any more than what they could mow. So they wouldn't want to say, I could do 40 lawns. That wouldn't work. They wouldn't be able to do all of that work. That'd be too much. So that's a good question to ask. All right, now we're going to do the got it. A child's height measures 105 centimeters. Estimate her height in inches. Well, we know that 2.5 centimeters equals 10 inches. Whoops, 1 inch, sorry. Got ahead of myself. Equals 1 inch. So because of that, they put 25 equals 10 inches. They just took it times 10 and got 25 equals 10 inches. Okay, so they put that in the table here. Now, I cannot take 25 times anything to get 105, so I need to scale back. And 25 and 105 are both divisible by 5, so I'm going to do that. I'm going to use 5. So what did I do to the 25 to get 5? I divided by 5. So I have to do the same thing on the bottom, divide by 5. 10 divided by 5 is 2. Now, 5 times what is 105? I can do 105 divided by 5 to find that out. 5 goes into 10 twice, which is 10. Bring down the 5. 5 times 1 is 5. Okay, so 21 is what I'm going to take it times. 5 times 21 is 105. I need to do 2 times 21. So 21 times 2 is 42. So 42 is our answer, but 42 what? 42 inches. That's our units. So 42 inches. Okay. All right. Let's look at page 42 now. Whoops, I did not clear that, did I? Let me clear that so we can go over that together. Oops. Okay. So the guided practice at the top, or the example at the top, number 5, is just like what we just did. On vacation, Leia exchanged 50 American dollars and received 60 Canadian dollars. Use a ratio table to find how many Canadian dollars she would receive for 20 American dollars. Set up a ratio table, use scaling to find the desired quantity. So she had 60 Canadian, 50 American. We had to scale back because you can't divide anything, 50 by anything to get 20. So we had to scale back to the 5. So we divide by 5, or by 10 to get 5, divide 60 by 10 to get 6. Now I can take 5 times 4 to get 20, and I'll take 6 times 4 also and get 24. So that's 24 Canadian dollars for 20 American dollars. All right. So it says that Santiago received an allowance of $7 every week. How much does he get after 4 weeks? So we've got 7 in 1 week. We could go straight to the 4, or we could do the table 1, 2, 3, 4. So if we do 7, or 1 times 2, 7 times 2 would be 14. 7 times 3 would be 21. 7 times 4 would be 28. And like I said, we could have just gone straight here. 1 times 4, 7 times 4. We didn't have to do all those steps in the middle, but sometimes you want to create that because maybe he wants to know after 2 weeks or 3 weeks how much he'll have in his allowance. Okay, so his allowance will be $28 after 4 weeks. Okay, guided practice number 2. Tanya runs 8 kilometers in 60 minutes. At this rate, how long will it take her to run 2 kilometers? So we have 8 and 2. We can't divide 8 by, well, we can. We can divide 8 by 4 and get 2, or we could just put 4 in the middle. Okay, and that's what I'm going to do, kind of do by steps, because 60 is a bigger number, and if you divide it by 4, it might get a little confusing. But if we break it down, it's a little bit easier to do. So 8 divided by 2 is 4. 60 divided by 2, half of 60 is 30. Then 4 divided by 2 is 2. 30 divided by 2, or half of 30, is 15. So that's pretty easy to do in your head if you break it down like that. So how long would it take her to run 2 kilometers? 15 minutes. Make sure you put your labels on these. Okay. All right, next, Lamika buys 12 packs of juice boxes that are on sale for $48. Use a ratio table to determine how much Lamika will pay to buy 8 more packs of juice boxes at the same store. So we have 12 packs for $48. Okay, and she wants to buy 8 more. Well, 12 plus 8 is 20. And we don't know how much that's going to cost. That's what we're trying to find out right there. Okay. Now I can't take 12 times anything and get 20, but I can find a number that would go in the middle, right? Something that if I divide 12 by something, I would get this number, and that number I could multiply times something else to get 20. So why don't we try 4? Because 12 divided by 3 is 4, right? And then 4 times 5 is 20. So 48 divided by 3 is 16. 16 times 5 is 80. So she's going to pay $80 for 20 packs. Okay. Now, you need to ask yourself with each of these questions, does that make sense? So she's buying 12 packs for $48, and 20 packs is just a little bit less than double that, right? So does it make sense that this number would be just a little bit less than double 48? Yeah, so that works, $80, okay? All right, now your homework is going to be page 43 all of this, 1, 2, 3, 4, 5, A, B, and C. And page 44, just the top, number 6, you don't have to do number 7. So you can cross that out. And then 8, 9, and 10 are extra credit if you choose to do them. You don't have to. They are higher order thinking problems, and they're a little bit harder. They're going to require more thinking. So if you don't understand those, that's fine. You don't have to do those. But if you want to try to do those for extra credit, by all means, go ahead and do those, okay? This will be due tomorrow. Well, I guess Wednesday, actually, because we don't have school tomorrow. Tomorrow is election day. It's a holiday, so there's no school. There won't be any online work for you to do, no Google Meets or anything tomorrow. You will be back in school on Wednesday. So Wednesday, I will see you guys back on Google Meets again, and we will be doing the next lesson in with this ratios, okay? All right, if you have any questions, you know how to reach me. You can email me, you can call me at school, or if you need a Google Meet set up with help with this, I can do that for you also. Have a good day, guys. See you later.